Well, good morning, everyone. Thank you to those who've been able to join us for the Georgia Association for Food Protection's virtual fall of 2021 meeting. My name, for those who have not had the pleasure of meeting in person as of yet, is Katie Murchison, and I am currently our association's president. We are really pleased to be able to welcome you today for a very exciting program. We will hear from esteemed speakers, including our Ayers Student Award winners for our 2021 cycle, and Chef John Szymanski from Kroger later in our program. I did want to just take a quick moment before we get started to let everyone know that this session is being recorded, and we will be able to provide a copy of the session on our Georgia Association for Food Protection website following this session. And, you know, given the disruption that we've all faced over the past several months, both professionally and personally, I just wanted to take a moment to recognize all of you, the quality, food safety, and academic professionals who've really demonstrated immense resilience and resourcefulness in the face of such uncertainty. Through your roles as food safety professionals within your operations, many of you have taken on the responsibility of leading your teams through the pandemic. And, you know, we know that that is in some cases a very natural extension of your calling to safeguard public health, but we wanted to just recognize your tireless efforts in helping to protect our food supply, and importantly, you know, your consumers, customers, and associates throughout the coronavirus pandemic. So thank you very much. And, you know, our board continues to send our deepest condolences to those of our extended Georgia Association for Food Protection family who've been directly impacted by COVID-19. As I just mentioned, this session is going to be recorded, so we will be able to share this meeting today with our attendees following this call. If you happen to get disconnected, please simply click on the event link to rejoin. And for questions for our esteemed speakers, we'd ask that you use the Q&A feature that's shown on this slide here to ask your questions to those speakers. Please don't send questions directly to the presenters, as they might not be managing the chat function during their presentation. So we'd ask that you can send them to the Q&A. And we'll have questions at the end of each speaker for our Ayers Student Award presentations. And then again, following Chef John Szymanski's presentation. But I would be remiss if I didn't extend a heartfelt thank you to our meeting host, the Georgia Tech Georgia Manufacturing Extension Partnership. We are immensely grateful for the partnership that we have with the GAMEP, and I'd like to pass it in just a moment to Wendy to share a little bit more about the Georgia Manufacturing Extension Partnership for those who aren't familiar. But as some of you may be aware, we initially were planning to host a hybrid meeting, and I did just want to extend a thank you to the Gwinnett Newton Rockdale Environmental Health Team for their willingness to host our hybrid meeting. And you know, as the pandemic evolves, you know, we do look forward to being able to resume in-person meetings at some point in the future, and are so grateful to our partners who are willing to host in-person hybrid meetings moving forward. But with that, I'll pass it to Wendy to share with you about the GAMEP.
Thanks, Katie. I appreciate it. Would you mind advancing one more slide, and we'll go back to this one? All right. Well, thank you so much. My name is Wendy White. I think I've probably met most of you. I'm your delegate to IAFP, a past president of this fine organization. And I'm also the industry manager for food and beverage for Georgia Tech's Georgia MEP. The Georgia MEP system, it's the Manufacturing Extension Partnership. We have centers in all 50 states and Puerto Rico. The focus of our department, it's a government-sponsored department, is to aid manufacturing across the country. It's kind of funny because, you know, when the MEP first started thinking about manufacturing, they thought about automotive, the aeronautics, you know, machine shops, things like that, and then quickly realized that food and beverage was a major player in the manufacturing industry. And so about 2 years ago, Georgia Tech asked me to come on board to open up this new division for them and focus on food and beverage manufacturing. And so we have support staff all across the state. I myself am focused on food safety, and we do a variety of services, trainings. I have actually a HACCP training in December. I'm co-teaching a PCQI certification training with Dr. Laurel Dunn at UGA in a week or two. And we also do on-site consulting work as well. So if you're interested, don't hesitate to reach out to me. And with that, Katie, I'll pass it back to you.
Thank you, Wendy. Now, I'd like to take a moment, in addition to recognizing the GAMEP for helping to support our meeting today, I'd also like to extend a heartfelt thank you to our 2021-2022 sponsors. We are extremely grateful for our corporate sponsors who provide financial and in-kind support to our organizations that enable us to provide content such as that you'll see today in our meetings, scholarships for our students, and really that support our mission to help keep food safe in the state of Georgia and beyond through providing information on protecting the food supply. The work that we do would not be possible without the support of our sponsors. So we are again, very grateful for your support and thank you. Now today, we're very pleased to be able to present the 3 recipients of our 2021 Ayres Young Investigator Awards. Wendy will introduce those speakers in just a moment, but they have some really interesting research that we are very excited to share with you, our membership today. And following their presentation and the Q&A sessions for each speaker, we're going to be hearing from Chef John Szymanski, who's the Corporate Food Safety Manager for Kroger, and he's going to share an industry perspective on the COVID-19 pandemic with a view from the prior year. I'd also like to share with you some updates from our executive board. Following our last business meeting on May 12th of this year, Cheryl Brown actually completed her term as president and now serves as our past president. I transitioned into the role of president. Jessica Chen transitioned from the role of vice president into our president-elect. And we're very pleased that Captain Charles Otto was elected as vice president to our organization and now leads our program committee. Both Dr. Eunice Ortega, Stephen Fuller, Wendy White, and Anna Townsend are continuing to serve in their roles as secretary, treasurer, student liaison, and IAFP delegate, respectively. But I wanted to take a moment here to recognize that the work that our organization does includes, these individuals, but also our committee members, whom of which are responsible for providing some of the programming that you'll see today. We would not be able to do the work that we do without the support of dedicated and passionate members of our committee and our board, of course. So I wanted to just take a moment to thank everyone for their contributions over the last year, and also recognize some of the achievements. We've certainly experienced quite the disruption as of last year. And in spite of that, our program committee was able to deliver 5 webinars on a number of timely and really interesting topics to our membership. Our award was actually awarded for the 2nd consecutive year, the Membership Achievement Award from the International Association for Food Protection. Our very own delegate, Wendy White, who you're familiar with, was appointed to the IAFP board as affiliate chairperson, and our student liaison, Anna Townsend, was recently awarded a Center for Produce Safety 2021 Professional Development Award. So congratulations to everyone, and thank you for your continued efforts to help advance food safety in the state of Georgia and beyond. And I would be remiss if I also didn't share with you that now is a great time to join and or renew your membership to GAFP so we can continue to provide the latest and greatest on food safety with each of you. You can check your status of membership by going to our Georgia Food Protection website that's listed below, and that can actually link you to the Join It page that you can check with your email to see if you are a current member. So we'd ask for you to please check on your membership status and renew that, as your membership dues help us continue to provide engaging content to our members. And finally, I mentioned the work of our committees is instrumental in the work that we do as an organization. We have 3 committees that you may have an opportunity to serve on. The first program committee is led by Charles Otto and develops our educational meeting content, including arranging speakers and topics, and the meeting logistics for our meetings and now, of course, webinars. The Membership and Public Relations Committee is led by Dr. Eunice Ortega and manages outreach. and membership expansion and fundraising efforts in partnership with our treasurer. And the Nominations and Awards Committee manages student scholarships, the honorary lifetime membership awards, and other developing opportunities that our organization gives. So if you are interested in getting involved, please reach out to any one of our board members, or I would encourage you to reach out directly to our secretary at gafp.secretary@gmail.com to join. With that, I'll pass it to Wendy to introduce our Jim Ayers Young Investigator Award student winners. Thank you.
Thanks so much, Katie. This is Wendy again, and I have the honor of introducing our 2021 Jim Ayers Young Investigator Award winners. This award was named after Dr. Jim Ayers. He was one of our founding members of our organization, beloved, loyal member, and he was a true mentor to young developing scientists. And so that's why this award was named in his honor. As a side note, I actually was a participant of this award myself, so it's definitely something that's near and dear to my heart. So I am actually going to go ahead and introduce our first award member, Xinran Xu. She's a food science PhD candidate at the University of Georgia under the direction of Dr. Mishra. She's originally from China and received her master's degree in food science from the Illinois Institute of Technology in August 2016, where she studied the decontamination of salmonella on packed flex pepper using pulse light technology. She worked in the frozen food company as a micro technician after her MS degree. And before that, she completed her undergraduate work at China's Xinran University, where she received a BS in food safety and quality. In her doctoral work, she's focused on risk assessment and predictive microbiology. She's actively associated with the Georgia Association of Food Protection and its parent organization, the International Association of Food Protection. Her long-term goals are to serve in academia in food safety and risk assessment area. In her spare time, she loves reading, traveling, and solving puzzles. So Xinran, I'll pass it over to you.
Thank you so much for the introduction. Hi, everyone. I'm Xinran, a PhD candidate at University of Georgia, working with Dr. Abhinav Mishra. Thank you so much for being here. My topic is to compare LASSO and classification and regression tree to predict E. coli prevalence in pasture poultry farms. I'm going to discuss my project from the following aspects. I'll start from the background and then move to the objective. After that, I'll briefly discuss the method and display the results, and then wrap up with the significance. The study aims at investigating E. coli prevalence in pasture poultry farms. So the questions are, what is pasture poultry and why we want to understand E. coli prevalence in it? Different from conventional poultry production, pasture poultry allows chicken to graze freely on fresh pasture with the movable pen and house to reside at night. The pen will be moved daily or every 2 days. In recent years, the interest and needs for organic or pasture products increased a lot. Also, consumers showed willingness to pay more for this type of products. In the meantime, there is an increasing trend of poultry-related foodborne outbreaks, especially for pastured or backyard poultry products. The increased risk of pasture poultry products is not only linked to the consumption, but also from the challenges of farm management practices and environmental factors. So generic E. coli is a common component of intestinal flora of warm-blooded animals. It has been used as an indicator for fecal contamination, indicating unhygienic handling during the processing and storage. It also shows the potential to indicate common foodborne pathogens in poultry, such as cattle, sheep, goats, and poultry. Those are identified as reservoirs for generic E. coli. As a result, there are multiple ways for E. coli to transmit to food. For example, improper handling during processing, fecal contamination after evacuation or cross-contamination during preparation and consumer's home. So the aim of this study is to first predict E. coli counts in pasture poultry farms, and second, to identify farm management factors affecting E. coli prevalence. The samples were collected from 11 pasture poultry farms from southeastern United States. Altogether, I have 2,295 samples where those were taken. I have 5 types of sample: feces, soil, WCRP, which is whole carcass rings after processing, and WCRF, which is final product whole carcass rings after chilling and storage, and Zika samples. These samples, the sample size of each type is listed in Table 1, and on each sampling day, the samples were taken from the area where the chicken resides, and the samples were plated and counted for E. coli. This table listed the farm management practices collected from the farm. 35 factors were included in the model. For example, average number of birds in each farm, the years of farming, type of bedding used during brooding. These are the explanatory variables in the model. Among these 35 factors, we want to know which of them have the potential to affect E. coli counts. LASSO is the modification of linear regression, where the model is penalized for the sum of the absolute values of the weights. And the targets of LASSO regression are to identify the variables and their corresponding coefficients that can minimize the prediction error. The pros of this method is it can avoid overfitting and perform feature selection, but the counts at the selected feature is not stable and is not intuitive to interpret. Another method we choose to use is classification and regression tree. It is a predictive algorithm used in machine learning. Different from traditional regression models, CAR method is a tree model. The advantage of the model is it does not require normal assumption and scaling of the data. The disadvantage are its instability of feature selection and its application in continuous response, and which needs more research on that. And how does this tree model work? It will develop by repeatedly splitting the data using a simple rule based on a single explanatory variable. And at each split, the variable that can minimize classification error or prediction error are selected. Let's move to the results. First, I want to give you an overview of the level of E. coli for different sample types. The fecal sample showed the highest mean E. coli counts of 6.46 log-10 CFU per gram, while the WCRF samples demonstrate the lowest mean E. coli level of 1.63, and compared to WCRP, which is 2.12, the mean E. coli counts were 4.01 and 5.23 for soil and Zika samples respectively. So in this figure, it shows the animal source is the primary rule to classify E. coli counts by CART method. The predicted E. coli counts of feces of cattle and swine were 1.4 log-10 CFU per gram less than the count of broiler and layer. A study carried out in Bangladesh reported that the E. coli level was 8.5 log-10 mpn per gram for chicken feces and 6.8 for cow feces, which is in agreement with our results. And this could be important for farms at risk multiple animals to prevent cross-contamination, especially if the animals share the common pasture. And also, we observed a seasonal trend of E. coli prevalence due to E. coli due to the high temperature and heavy rain, which may aid in the growth and transportation and microorganisms. So samples collected after 1/14, which is early November, were thought to have lower E. coli counts comparing to hot months from June to September. In a study carried out in Morocco, the level of E. coli was significantly higher in hot seasons, which is from April to September, than in cold seasons from November to March on chicken carcasses. In this figure, it shows the tree model for WCRP samples. The rinse water, whether it's chlorinated, is the primary rule to classify E. coli counts. The E. coli counts of WCRP samples treated by organic acid water were 1.8 log CFU lower than the treated with other methods. A study showed that the E. coli counts were reduced after chilling using 25 ppm chlorinated water in a broiler slaughterhouse, which agrees with our data. Moreover, another study reported a 1.4 log CFU reduction of E. coli before and after chilling with 20 ppm sodium hypochlorite. The application of chlorinated rinse water or organic acid rinse water in broiler slaughterhouse could effectively control the E. coli population. Whether the brood feed have soil or not is another feature selected to predict E. coli population. The boilers with soil-based diets show the lower predicted E. coli population, which is 0.84 comparing to 1.636 for boilers with soil-free diets. However, soil-based diets showed higher Campylobacter prevalence in soil samples on pastured poultry farms in a study, and also in a microbiome study showed that the soil-free or soil-based diet did not significantly affect the fecal microbiome composition. So the impact of soil-based diet on the presence of indicator organisms and pathogens in boilers requires more research. In this table is summarized the MSE, the mean square error of LASSO and classification and regression tree model. For soil and WCRP samples, CART methods perform a little better than LASSO, and for WCRF and SICA samples, CART and LASSO perform almost the same, and in the fecal model, LASSO is better than CART. And both these two methods work relatively well in predicting E. coli prevalence and identifying related vectors. And one drawback of this method is confounding factors were found, but there was really no better way to address this issue. To wrap up, our study helps understanding E. coli prevalence in pastured poultry farms, and also it helps identify possible factors affecting E. coli prevalence, and also it provides the potential to integrate the model into risk assessment. This is my reference, and thank you so much for listening. I'll take any questions if you have.
Thank you, Xinran. That is, it's such important research, especially in Georgia, where chickens outnumber people, I think, by a significant number. So just to remind everybody, if you have a question for any of our speakers today, please go ahead and put it in the Q&A section that's on the bottom right hand portion of your screen. And remember, after you type in your question, you have to hit enter or hit send so that we can see that. Xinran, one question that I had for you, you talked about the factors, the variables that affect these numbers, like the number of birds handled and the season and the flock, the bedding type. What factor do you think, what variable do you think has the greatest effect on these numbers in the pathogens?
First, it really depends on the data and the model we did, and based on our research, I think that the animal source is one of the most important factor that affecting E. coli counts in these type of samples. Especially if the animal share the common pasture, it's really easy to cross-contaminate and pass E. coli from one animal to the other. Thank you. I hope I answered this question.
Okay, that's really interesting. I appreciate you saying that. All right. Well, I don't think that there are any other questions, so we will go ahead and move on to our second speaker. Hold on just a second. All right. Kane Cooper is a recent graduate. Sorry, that's my fault. Kane Cooper is a recent graduate from Emory University's Rollins School of Public Health, where he obtained a master's in public health and environmental health and epidemiology under the direction of Dr. Juan Leon. Kane is originally from Gaston, North Carolina, and prior to attending Rollins, he graduated from UNC Chapel Hill with a double major in biology and chemistry. His undergraduate research in Dr. Rita Tamayo's lab focused heavily on Clostridium difficile protein pathways related to colony morphology and motility. Ultimately, this played a role in the bacterial pathogenesis of this pathogen. Continuing to pursue his passions for infectious disease research at Rollins, Kane's been involved in the laboratory direction of norovirus from farm workers' hands and produce rinse samples. In his thesis, he focused on quantifying the risks of SARS-CoV-2 infection among essential food workers. He's currently applying to medical school in the hopes of combining his public health and infectious disease research background with primary care skills necessary to actually treat these patients that are disproportionately affected by these pathogens. So with that, Kane, I'm going to pass it along to you.
All right. Thank you so much, Wendy. Thank you for that intro. So like she said, my name is Kane, and I will be talking to you all today about my master's thesis about characterizing the risk of SARS-CoV-2 infection among essential food workers using a quantitative microbial risk assessment approach. And so first, to provide a little background, a recent study in the California economic sectors had identified the food and agricultural sector as experiencing the highest excess mortality rate due to SARS-CoV-2. And as we all know, these workers are pretty essential to maintaining the food supply, even whenever we're not in a pandemic. And so we've hypothesized that the close contact nature of the agricultural work, be it in the fields while they're handling produce items, or in an indoor packaging facility while they're packaging items, this close contact nature of their work could be related to the excess number of infections. And so our key research questions that I was hoping to answer with this work is, what is the daily cumulative risk of infection among indoor and outdoor workers? And what interventions are effective at reducing this infection risk and hopefully limiting future outbreaks in the agricultural workforce? So to get at that, we have to walk through this messy schematic. And so this is our QMRA diagram. And so essentially, to walk you through it, over here on the left side, I don't know if you can see my mouse, but on the left side, we have a worker. This is an infected SARS-CoV-2 positive worker. And so they are exhibiting symptomatic symptoms. So they are coughing and they are producing small diameter aerosols. And these aerosols are denoted by the black viral particles. And so these are small and they'll persist in the air. And so that's why we have this top box, this top blue box. And so they'll persist in the air and they'll kind of stay in the air because they're small. And they can reach distances greater than 3 meters from their point of origin. And next we have these larger diameter droplets. And so these are going to travel within 3 meters from the coughing individual. And so due to gravity, forces of gravity, and also the size of particles, they will fall out and infect or contaminate potential surfaces. So this could be either like a table surface or a food packaging surface. And so we can have indirect transmission through a worker, a susceptible worker, touching these surfaces and then potentially contacting their face. And so summarizing all of that together, we can get a dose to the susceptible worker and run that through a dose response model to get to the risk. And so in these gray boxes all around on the left side, these are all of the interventions that we can turn on in our model. And so mainly talking about face masks. So we have, in this model, we have cloth masks. So both the infected and the susceptible worker will be wearing cloth face masks. We also have air exchange rates. So this is kind of the rate of air recycling in a particular scenario. So bringing in fresh air and exchanging with the old air. We also have surface disinfection. We have hand washing and glove use. And then we also have partial and full vaccination. And so to walk you through the kind of daily life of a worker, we have these modeled scenarios on the right. And so the first one, trying to make sure. Okay, first one is the shared transportation scenario. And for this scenario, we're imagining that the workers are going to be spending an hour going to work in the morning and also an hour coming home from work in the evening. We've hypothesized that the infected worker is going to be driving the car and the susceptible worker is going to be in the back seat. And so this means that the susceptible worker will really only be able to be exposed to the aerosols that are accumulating in the car. Next, we have our outdoor field harvesting scenario. So this is a 12-hour outdoor working shift, and we're assuming that the workers are going to be facing each other while they are processing their fresh produce items. And we're assuming that they are going to be exposed to droplets only due to the aerosols really being taken away by the natural ventilation that's happening outside. Next, we have the indoor packaging facility. So this is again, a 12-hour work shift. Again, the workers are going to be facing one another while they are processing their items, and they are going to be exposed to both aerosols and droplets. And lastly, we have our shared housing. So this is going to be 10 total hours living in a studio-style apartment. And so of those 10 hours, 2 of them are hypothesized as having kind of a close contact interaction. And so this kind of accounts for any time spent either cooking together or cleaning, eating together, anything like that. And so in this scenario, they're going to be exposed to both aerosols and droplets. All right, so taking all of that together, we can look at the risk in each of these individual scenarios, but then also get a look at the risk of their daily across all of their scenarios of the entire day. And so here on this figure, we can see the top row, this is for an indoor worker. And so on the second row here, this is for an outdoor worker. Each shade of blue represents the particular scenario that we just discussed. And each number within those boxes represents the risk of infection in that scenario. And so as we can see, if we're assuming that there is an infected worker in each of these scenarios, by the time the worker, the susceptible worker is on their way home, they've already reached a 100% risk of infection. And so really the key takeaway with this is that both the indoor and the outdoor worker experience an excessive risk of infection throughout their daily lives. And so now to kind of transition into more of the positive side of things on what we can do to kind of reduce this risk, we first wanted to look at vaccinations. And so here on the left, you can see how the color corresponds with the range of risk values. And so in the table, this top row is going to be our baseline scenario. So each column is representing each individual scenario. So our morning, evening transportation, indoor, outdoor work shift, and then our residential space. And then this final column is going to be the cumulative risk of infection across the entire day. And so this first row, we're looking at no interventions, no vaccinations or anything. And so we can see that there is a cumulative risk of, like we said earlier, 100%. And so this next row, the second row, this is our partially vaccinated workers. And so this is assuming that both of the individuals, the infected and the susceptible, are both going to be partially vaccinated. So they'll have 1 dose of the 2-dose series. And the symptomatic worker is experiencing a rare breakthrough infection. And so as we can see on the right, the risk reduction is around 61% for both the indoor and the outdoor worker, which is great. And then once we get to the fully vaccinated, this is assuming that both workers have received 2 doses of the 2-dose series vaccine, and that, again, the infected worker is experiencing a breakthrough case. And so as we can see again on the right, they have an 88% reduction in risk for their entire day. So taken together, vaccinations can reduce their risk from over 100% down to around 12% if applied. And so next, we wanted to look at packaged non-pharmaceutical interventions. And so the table setup is the same. This first row is going to be the same. This is our baseline with no interventions applied. And so this first intervention package is, I'll just name them off. So it's increased air exchange. So this is going to be situationally appropriate. And so this could take the form of, say, in the transportation scenario, this is going to be rolling the windows down while you are going to work and driving. For the indoor facility, this is going to be equivalent to increasing the air exchange, increasing the air exchange rate. There's another word for it. But then the residential space, that's going to be representative of opening a window and kind of increasing this natural ventilation in the space, in the apartment space. Ventilation was the other word I was looking for. And so we're also looking at universal cloth masks. So again, the infected and the susceptible worker are both wearing cloth masks. We're looking at hourly hand washing and surface disinfection. And we're also, this is just a reminder that we're looking at shared housing. So both the infected and the susceptible worker will be in the same residential space. And so on the right, you can see that these non-pharmaceutical interventions are capable of reducing the risk of infection by 87% for an indoor worker and 84% for an outdoor worker. And so we really wanted to see what we could do to get this risk below 10%. And so to do that, we targeted the riskiest scenario. And so that's why in package 2, the only difference is this private housing addition. And so this is hypothesized as the workers are still going to have that 2-hour time period spent together, say eating or cooking together in their residential space, but then for the remainder of the time, they're going to be in sort of a private living quarter. So they won't be able to have any contact with one another. And so after implementing that change, that was able to reduce the risk of infection by 92% for the indoor worker and 90% for the outdoor worker. And so the key takeaways I would like to leave you with is that the daily cumulative risk of infection can exceed 100% for both the indoor and the outdoor workers. Vaccinations and non-pharmaceutical interventions are effective at reducing the risk of infection, and more emphasis is needed on increasing vaccination uptake and continued use of non-pharmaceutical interventions for this worker population. Last few things. Our future work, this is going to be leveraging this QMRA within infectious disease transmission model in order to understand the effects of variable vaccination rates and variable use of interventions at the population level, and then also used to characterize the risk or characterize the impact of evolving strains of SARS-CoV-2 and the impact that that will have on our workers. And lastly, just thank you to my research team, everyone listed here, and I would be happy to take any questions.
All right, thank you so much, Kane. We do have one question. Hold on just a second. Let me lift this up so I can read it. Our question is, in this hypothesis, do the mask type, duration of transport, and living quarter space all presume the worst case scenarios?
Yeah, so that's a great question. So we like to consider our models sort of conservative estimates in order to give a worst case picture. And so a lot of our ranges for, say, mask efficacy or just different parameters will have various ranges. And so that way we're kind of being inclusive of like both the best case and the worst case scenario in order to kind of present sort of somewhere in the middle. And so that's hopefully what we've done with this model.
All right, so we have one more question. This one's a tricky one. I don't know if the research actually gives you this, the answer to this question or not, but if vaccination significantly decrease the chance of infection, is it still necessary for vaccinated employees to also wear face masks?
Yeah, so that's kind of the question that I'm getting at now with my research, where it's combining both these sort of non-pharmaceutical interventions and also the vaccination type, so either partially or fully vaccinated. And as we can see, I can go back to the slide actually. Vaccination, so if you have totally, like completely vaccinated workers, there's still going to be a 12% chance of infection, assuming that the infected worker is still symptomatic. And so this is like best case kind of with fully vaccinated workers. And so kind of the work that we're doing now that I'm not really showing here is indicating that combined interventions, both these non-pharmaceutical interventions and also vaccinations, are the most effective way at reducing any kind of chance of infection at all.
Okay, so, you know, I think what you're saying is vaccination is definitely probably the most efficient way, effective way to have that protection, but layering these different protection activities is definitely better than just one or a few together.
Exactly, yes, yes.
So, you know, pretty much what we've known now, and hopefully we can get to a point where the vaccination efficacy is good enough and our percentage is strong enough that we can start to kind of taper back some of the other protection activities that we have.
That's the hope.
All righty. Well, thank you so much, Kane. I appreciate it. And next, we're going to go to our final presenter. Julia Sobolik is a rising fifth-year doctoral student in the environmental health sciences at Emory University. Her research interests include evaluating viral contamination of fresh produce, informing best practices for reducing workforce exposures to enteric and respiratory pathogens, and improving pathogen detection methods from hands, foods, and environmental surfaces. She's particularly interested in norovirus exposure pathways in the agricultural farm environment and interventions that reduce infection rates among fresh produce consumers. Additionally, over the past year, she's developed a quantitative microbial risk model to evaluate SARS-CoV-2 risks and risk mitigation strategies for essential workers in an indoor food manufacturing facility. Julia holds a BS in biology from Oregon State University and a Master's of Public Health and Global Health from Emory University. She also has an MS in microbiology from the University of Washington. So with that, Julia, I am going to pass it over to you.
Great, thanks, Wendy. So I would just like to thanks again to GAFP for having this fall meeting and for inviting us all to be speakers. And again, it's an honor to represent Dr. Jim Ayers as an awardee. And with that, let's dive in. So it was a wonderful introduction from Kane because we're going to just continue this theme of talking about SARS-CoV-2 transmission risks and risk mitigation strategies among essential workers, and in this case, we'll really be focusing on an indoor food manufacturing facility. Okay. So there are two takeaways from this talk that I hope I'm effective in communicating. So the first is taking a step back and really wanting to share that the quantitative microbial risk assessment frameworks of QMRA is really an effective tool for characterizing pathogen exposure and estimating infection risk, and this is largely at the individual level. And so as Kane alluded to, often we like to also translate the individual infection risk to the population level, and that's some work we'll be presenting hopefully in the future. And then the second takeaway is that we, hopefully I'll convince you that we have recommended infection practices will effectively protect indoor workers from SARS-CoV-2 infection. And so hopefully this will be not a surprise from all the work that everyone's been doing over the last 18 months, but that this will provide evidence base for the continued implementation of these infection control strategies. So as always, I'd like to acknowledge my research team. So this work has been supported by Drs. Juan Leon and Leanne Jacobs. You just heard from Kane, which is wonderful. And then also we have a fifth-year PhD student who's in my cohort, Elizabeth Sayevsky, who's leading forward with that population level transmission model. So you've actually already, know all of this, and you've just heard most of this from Kane. But just to really bring this home, we know that the COVID-19 global pandemic poses a significant health risk to food workers. As Kane alluded, when we look across occupational sector relative to historical records, that the highest excess mortality increase of 39% was among food and agricultural workers. So we really want to focus on this high-risk population. And we know that these workers are essential and necessary to maintaining the U.S. food supply. There's also dynamic factors associated with these worker populations that pose challenges. And so these are permanent, these are seasonal, these are immigrant status workers that sort of complicate how we handle different infection control measures. And now there's more evidence, and hopefully this work will advance that as well. But there has been limited evidence supporting which best practices should be implemented for COVID-19 prevention. And so really the goal of this work was to evaluate the recommended recommendations, for controlling SARS-CoV-2 transmission, and to really prioritize risk management strategies within the context of an indoor food manufacturing facility. Okay, so just to make sure we're all on the same page, I just wanted to very briefly go into what do I even mean when we're talking about applying the QMRA framework, what the QMRA framework is. And so you start with your hazard identification. So in this case, this would be our SARS-CoV-2 virus. And then you move into an exposure assessment. And so I know you can't see my cursor, but basically everything you see in this figure, I like to think it's crammed into this box. And so what this means is that we're sort of understanding how someone would be exposed. And so you have an infected individual, which is shown on the left under the emitter. And so they will be, for instance, coughing and having an expelling of viral particles contained in large droplets, which would potentially be your near field exposure, smaller droplets, which could be considered aerosols in your further field exposure. Of course, you could have contamination on fomites, which is shown in the puddle on the floor. And then what's captured really well in this figure is that there's other dynamics. So there are environmental dynamics that are captured in this aerosol particle transport. There's also temperatures, viral decay, and then there's also individual physiological factors. So all of this taken together, we cram into that box, and this is our exposure assessment. And so it's important for you to note that we built our model with input from trade associations, driving parameters for the model from the published literature, and that we really grounded this model in the best evidence that we were able to collect. And then once you have this estimate, so in your exposure assessment, you are basically trying to estimate the dose of exposure. And so you take this viral dose and you move it into your dose response. And what you get out of your dose response is essentially this association or this relationship between the amount of virus potentially exposed to an individual and the likelihood or the risk of infection. And so this essentially is a mathematical model here that will give us that estimate of risk. And then once we know our risk, we're able to then look at different risk mitigation strategies, right? So you can have a relative risk at a baseline condition, and then you layer on different interventions, which of course is what we're interested in. And then you have this relative risk or relative risk reduction. And ultimately, what we're wanting to inform are these different risk mitigation strategies that can lead to best practices for the industry. And so a few items for you to note. So as Kane alluded, and that was an excellent question, this is a conservative model. So one aspect of it being conservative is that we are using a modified SARS-CoV-1 dose response model, as there is currently not a SARS-CoV-2 dose response model. So in this case, these are conservative, sort of more worst case estimates. However, we have tailored that so that these are still realistic. And we did that by calibrating. So I mentioned we got inputs from trade associations, from the published literature, But then we also calibrated our risk. So not only, because we want to make sure this isn't too far off. And so we calibrated our risk against published outbreaks that were well defined in terms of distance and exposure time. And so those are really important for basically being able to say, what is real and where does our model sort of line up against that. And so specifically, we calibrated our 1 hour within close contact risk to about 30%. And that was based off of 2 published studies. Okay, so then now that we all are grounded in the QMRA framework, let's move forward with what we did. So as Kane alluded to with his work, we had 2 primary research questions with this work. And this was within a food manufacturing facility that's indoor, looking at essential workers. Our first question was, what is the transmission mode that results in the greatest risk? So specifically, this near field versus far field or fomite mediated. And you'll notice here that the near field is incorporating both aerosol and droplets, whereas in far field would be your small aerosol particles, and fomite would be any inanimate surface that would be contaminated by aerosols and droplets. And then of course you have a hand contact and viral transfer to your hand and then to your face. And then the second question was looking at how well do worker protection strategies function as infection control measures. So this is really what we're most interested in. Okay, so again, Kane did all the work for me, so this is fantastic. But just to bring us all again to the same page, so what we're showing here is the QMRA schematic that we use to base our model off of. And so I know there's a lot here, but just to briefly walk you through this, on the left is going to be your infected SARS-CoV-2 worker. On the right is going to be your susceptible worker, and we're characterizing the risk to this worker. And then what's shown in red, sort of red text, is going to be your different transmission pathways. So in the blue boxes, you have your aerosol reservoir on the top. And following that pathway, you have your far field exposures. So this is be defined as greater than 3 meters, distancing or 9 feet. You have your near field, which is droplets and aerosol exposures, and that would be defined as less than 9 feet, less than 3 meters. And then finally, you have that bottom blue box would be your environmental reservoir. So this would be your fomite surface. And then what's shown in gray are all of our intervention strategies that we that are informed by current recommendations, but then that we also want to investigate. So you have source control in terms of mask use for both your infected worker as well as your susceptible worker. Air exchange, which is defined as the complete turnover of the air volume of a room per hour. And then across the bottom, you have your more fomite mediated targeted intervention. So you have your surface disinfection, frequency and efficacy of the product that you're using. You have your hand washing and glove use, again, compliance and frequency and efficacy. And then as Kane noted, and similar to this analysis, we have vaccination. And so I'll go into that in a little bit more detail, but this will be vaccination of both workers, the infected as well as the susceptible. So important to note here as well is that we looked at several different distances between the infected and susceptible worker. We looked at different exposure times. And then what's shown in this orange box is just basically the differential in terms of exposure, distance to different droplet sizes. And so what's important to note is that the largest sort of percent of fluid expelled in a cough, so this is sort of graphic, but the largest sort of fluid expelled in a cough is going to be comprised of large droplets. And so then as you move further away from someone with these large droplets, you're going to have less volume exposure. And so this comes into play when we think about viral exposure. Okay, so then to focus on our first question of which transmission mode results in the greatest risk, what I'm showing you here is we have 8-hour exposure risk on your y-axis, and then you have time across your x-axis. And as you'll note here, you have your near field, which is the top arrow is basically indicating over time, you have your near field. So this is defined as 3 feet or 1 meter. You have the greatest risk. And so this is similar to what Kane was showing in that you have almost 100%, you almost saturate the dose response model. And again, this is so cumulative risk over time. And so this feels quite large. This is in the absence of any interventions. And then notably, as soon as you start to have distancing away from the infected individual, you have a reduction in your risk, right? So for your far field, which would be defined as greater than 3 meters away, you have a 5% risk. So again, in the absence of any interventions, your closest distancing to your near field is going to result in the greatest risk. And so this is intuitive, right? So we know that with the more distancing you have, the safer we feel. And so this would be evidence to support that. And so then again, just to really bring this home, that just by having distance alone incorporated, you have an 84 to 91% reduction. So distancing is very effective. Okay, so that sort of answers our first question. So to answer our next question, we're going to now look at these interventions that, that we are going to do individually and then combined. So to walk you through this, this is now looking at mask use alone. And so to go back to that question that Kane received, we know that there's many different types of masks. We know that the filtration efficiency of the different masks varies. And so this was our take at basically trying to incorporate several different types of masks that we know are being implemented across different types of facilities, different different worker conditions, and then look at distancing across the top. So what's most notable and what's shown in these black boxes is that masks work well and they work even better at distance, right? So you see, especially as you improve sort of the filtration efficiency of your mask. So for instance, cloth masks don't work all that well. However, they do reduce your risk by about, let's see, 50%. So cloth masks reduce your risk by about 50% when you're at 1 meter. However, if you can move to 2 or 3 meters, your cloth masks are going to be working even better, right? Surgical masks we found at 3 meters would reduce your risk. And again, similar to Kane, we kind of had a risk threshold. So we were really trying to get at where do you have your lowest risk? So you would reduce your lowest risk to about 1% if you are pairing your surgical or your double masking at 2 and 3 meters. And then of course, N95s work the best. So this should give you a sense that masks do work and they work the best at further distances. Okay, and then now, so this idea of we are not doing, particularly now, 18 months in or more, we're not doing interventions in singles, right? We're doing a combined approach. And these are also mirroring GMP practices. So what I'm showing you here are going to be, again, results that are bundled. So this is going to be hand washing twice per shift, surface disinfection once per shift, and then the combined effect of what's shown as you go in your furthest left column down. So incorporating air exchange now and masks. And so what's this sort of orange top is going to be your baseline no intervention, so your sort of worst risk. And then what's shown in blue are these combinations. So what we see again is that in this case, your distancing is important and paired with multiple interventions. So at 2 meters, actually all of the risks, all of the risks which are highlighted in the black boxes, and then all of your percent reductions are in the parentheses below. But all of your risks are less than 1%, particularly at 2 meters with all of the bundles. So with your air exchange of 2 air exchanges per hour, with your cloth mask, surgical double masking. So this should feel, hopefully this makes everyone feel better and good that within an indoor facility, that risk can be quite low, particularly when you're bundling all of your interventions. Okay, and then the final set of data I'm going to show are now looking at vaccination. So those prior interventions were in the context of no vaccination, now looking at vaccination. And so what I wanted to show here, so on the left is going to be so 2 different things. So one is full immunity. So what I wanted to define here is that in this case, both workers are vaccinated. And so full immunity would be that the workers have received both doses of a 2-dose mRNA vaccine. Partial immunity is defined essentially as at least one dose. And partial immunity also sort of captures, and you'll notice this is the dose, the vaccine effectiveness on the left. So you have your higher vaccine effectiveness associated with your full immunity, your lower sort of reduced vaccine effectiveness with partial. And the way we sort of did this was that we wanted to think, okay, if you have either a mix of workers in terms of how well they're protected due to their vaccination, or if you were to have waning immunity, or if you were to have other sort of confounders that would impact how well they are protected, these data essentially were designed to capture that. So again, this is the idea that you would have vaccination of both workers, at least one dose of a 2-dose mRNA. This would be, again, looking over an 8-hour shift. So as I start to bring in these results, there's a lot here, and I wish I had my pointer. But basically what I wanted to show you is that across our bottom is risk. And when you see none, this is basically our baseline risk where we had no interventions, no vaccination. So this is, again, our high risk. And then what's shown in light blue is partial. So if you are partially vaccinated, so with a reduced effectiveness, so again, think of this as sort of both workers are vaccinated, but potentially they have some waning immunity. Without any interventions, but with vaccination alone, you reduce your risk to about 26%, so from 98 to 26. The benefit though, and this goes to that question and that Kane nicely answered, the benefit is when you layer on additional intervention. So what we're showing here now is vaccination plus mask use. So when you have, again, sort of reduced effectiveness of vaccine, but you're wearing double masks, your risk is reduced to less than 1%. The biggest benefit is when you have full immunity vaccinated workers, which is shown in the dark blue, and you have going from no vaccination to vaccine alone, you reduce your risk from 98% to 8%. And then of course your benefit when you start to layer on your mask. And in this case, cloth, surgical, and double all work well. So this is in the rare event of a breakthrough infection among 2 vaccinated workers. But what we can see is that you really do need to pair your existing intervention strategies, and here we're modeling mask use as well as vaccination. So vaccination alone is not going to protect your workforce entirely. Okay, so just in terms of wrap up, our key takeaways are that your SARS-CoV-2 infection risk is heightened for workers with near field exposures, okay? We are also able to show that your bundled interventions are going to really be the most effective, and these are targeting those near field exposures as well as the respiratory droplets. Vaccination combined with our intervention strategies, so this is what I just showed, are effective, but not effective alone. So vaccination really does need to be paired with these infection control measures. And that really, hopefully this lends some relief to everyone to realize that these combined recommended infection control measures do effectively protect workers in an indoor food manufacturing facility. And I should caveat that this analysis is done at ambient temperature. So this is really focused at whole fruit and vegetable manufacturing. Some additional analysis that I haven't shown here, but that we did was to look at reduced temperatures. So if you were to transition more into a meat packing or a frozen food sort of type manufacturing, indoor manufacturing facility, and the impact of sort of this reduced temperature. And what we were able to show is that the bundled interventions effectively work even under these colder temperatures. Okay, so the next steps, and these are nicely commented by Kane, is that we're taking this work and we're moving it from the individual infection risk to the population level. And this will allow us to help answer some of these critical questions of, when you have heterogeneity in your vaccination coverage among workers, and how do you introduce or remove different NPI, non-pharmaceutical intervention practices, as well as potentially doing different testing levels. So I know this will be exciting work for people in the future. We're also looking at frozen food packaging as this and fomite-mediated risk associated. And then you just heard the nice work from Kane. So we're excited about this research and hope everyone can stay in touch with us. I'd like to acknowledge our research team, and again, this opportunity to present, and for this Jim Ayers Young Investigator Award, and I will happily take your questions.
Thank you, Julia. That was really interesting research. We really appreciate the presentation. And we have a couple questions. I actually had a question, and then Janice actually had a very complimentary question. So I'll ask mine first and then hers. We saw that the different types of masks definitely offered a difference in reduction. And definitely wearing a mask makes a difference, but does the type of mask, is it a significant reduction? Is it a significant difference? Or is it just that you need to wear a mask?
Yeah, this is a great question, and we've been considering this internally as a group. So generally, we do not do statistical tests on these different scenarios in which we have a relative risk estimate, and we're comparing across different types of masks. For instance, our general practice is not to do statistical tests, largely because and this is something I welcome feedback. This is a simulation, and so we are basically doing 10,000 iterations of our Monte Carlo simulation. And so it feels a little artificial to do a statistical test on a mathematical model that we have control over how many different runs that we're doing, if that makes sense. So we have not done a statistical test to compare the different types of mass and whether one is significantly better than the other. However, I will say consistent, so with our work, which we showed, and then consistent with evidence coming out from CDC, et cetera, we do know that improved mass, so surgical relative to cloth, and then double masking, which would be surgical paired with cloth, that as you improve your filtration efficiency, and this is, and fortunately more data is coming out regarding this, that you do have increased protection. So the current recommendation would be ideally to improve the type of mask, right? So surgical above cloth or double masking would be even superior.
So the surgical, is that just a disposable mask or is that an N95?
No, sorry, good question. So it would be the disposable, and I know there's a better term than like the medical surgical mask, but it would be like the disposable 2 or 3 layer, I guess like medical grade type of a mask. Yeah. The N95s we know are K95s and N95s we know work very well, but we also know those are not routinely being implemented in a manufacturing facility. So I mean, if in a perfect world, if everyone could wear K95s or N95s, I think that would be our evidence shows those work the best. We also know those have the best filtration efficiency in terms of protecting the wearer. However, we know that's not routinely being implemented in these settings.
Ah, gotcha. So Janice's question is, in the double mask scenario, what types of masks were those? Does mixing and matching them help in any significant way? What are your thoughts on that?
Yeah, that is a great question, and I really appreciate that the audience has dialed into these nuances. So these are fantastic. So the double masking is defined specifically as the CDC. So this is a let's see, it's a surgical mask first. So in this case, a disposable, multi-layer mask first, followed by a cloth mask. So as defined by the CDC. And so the rationale here is that we know that there's what impacts sort of your efficiency of how well protected you are by a mask is not only the material, the types of materials that are being incorporated into the mask, but as well as the fit. So the idea here is that the surgical masks, actually, these disposable masks offer better filtration efficiency and protection of the wearer. But then your cloth mask, often, there's those gaps on the side. So the cloth mask actually sort of adheres the mask better to your face. So per the CDC guidelines, the recommendation, if you were to do double masking, would be that disposable mask first, followed by a cloth mask that really adheres it to one's face.
Great. Well, thank you so much.
Thanks, Wendy. And yeah, we didn't look at any other combinations other than that sort of order and those specific types of double masks.
Okay, sounds good. Well, it's always room for future research. With that, I am, unfortunately, we've kind of run out of time, so we have to move on, but I wanted to thank all of our student speakers so much for their amazing presentations, and I think that the work that you're doing is so applicable to the community, and the folks that we have on here today. We had Xinran, she talked about the poultry farming out in the field. Georgia definitely sees a lot of that. Kane then took it on with the application of infectious disease out in the field and the growers. And then Julie really rounded it out beautifully by kind of bringing that in-house to an internal manufacturing site. So thank you all to our students, all of our students, not only our winners, but we have many, many Georgia Association of Food Protection students that are out there doing amazing research. And with that, I'm going to hand it over to my colleague, Captain Otto, and he is going to introduce our next speaker.
Thank you, Wendy, and all of the students. Congratulations again on your winning the John Ayres Award. That is quite an honor. And if you look back in a lot of food safety professionals' background, you will find that winning that award is always mentioned in their biography. So it's very significant, and I appreciate all the association support of our students. Chef John, could I get you to advance to your first slide, please? It is my pleasure to introduce our featured speaker today, Chef John Szymanski. He is a certified executive chef administrator, and certified professional in food safety. He is a summa cum laude graduate of Johnson Wales University in Miami. He's been with Kroger for over 25 years here in the Atlanta division. And there he heads up the food safety and regulatory compliance efforts of 186 stores, and he's constantly working at that. I wanted to lift up his other background outside of Kroger at first. He has been recognized by the American Culinary Federation as the Chef of the Year, and also has received the Presidential Award. And on the soft side of Chef John, he has also received twice their Humanitarian of the Year Award, and has been recognized as the international citizen of the Chef Scholarship Foundation, the World Chef Scholarship Foundation. He's been very active in the future of culinary endeavors as well as food safety. He is serving on the board of directors of the Hospitality Education Foundation of Georgia, and worked with the Fulton County Schools and the Georgia Grown Chefs recognition program by Governor Deal and the Agricultural Commissioner Gary Black. He is active in food safety professional organizations such as the Georgia Environmental Health Association, and has served as past president of our own Georgia Association for Food Protection, and he's a current member of our board. On one light note about Chef John and his career, he served as a national judge in the Pillsbury Bake Off, and with that he actually got to punch the doughboy, he said, in his stomach. So that is probably a unique experience for Georgia Association for Food Protection members. He probably resembled your experience when you got called in your own field and said, "What do you know about SARS-CoV-2 or COVID-19 or the coronavirus?" Because he was named as the pandemic coordinator for the 183 locations of Kroger in the Southeast. That includes Alabama, South Carolina, and Georgia. And today he's going to be bringing us a talk on COVID-19 and industry's perspective a year later. So please help me welcome Chef John.
Hey, thank you so much. And that was absolutely outstanding, Captain Otto. I appreciate that. That's making me blush a little bit. But I want to say congratulations to the students. Absolutely outstanding presentations. They were extremely well done. And as you can see from what I'm going to be speaking about, a lot of those interventions have been put into place with Kroger. What I'm going to do is I'm going to shut off my camera just briefly while I toggle through my notes. It's going to help me not be distracted as much, if you don't mind. So first, as I look through all the participants, it's amazing to me. So many names that I am familiar with. I've worked with many of you in the past, and I currently work with you on SARS-CoV-2 protocols and what we're doing currently. And we really appreciate all of the camaraderie that we have, but also the interaction with academia, industry, as well as regulatory. And I want to say thank you to GAFP, Katie, and Captain Otto, and the board for allowing me to share Kroger's pandemic response and ongoing efforts to keep customers and associates safe during this worldwide pandemic we're all living through. And I echo what Katie had said earlier. Our hearts and prayers go out to everybody who've been affected by SARS-CoV-2. And again, Kroger, we have so many people who are on the front lines each and every day. We felt it internally as well. So again, hearts and prayers to everybody out there. I want to thank all of you on the call and on this presentation for what you do each and every day. I see members from the CDC, the state and county health department on here, State Department of Agriculture, as I'm scrolling through. We have transportation, academia, industry, and we're all dealing with this worldwide pandemic together. So a special thank you to all of those, especially those on the front lines and those who are the essential food workers for keeping the food flowing during all of this. As we talked about on some of the earlier presentations, essential workers such as manufacturing, transportation, and retail food service, Kroger, as well as all of our competitors. We've been there on the front lines and we've been providing safe and wholesome food throughout this pandemic. So we really thank you for everything that you're all doing. I'm going to advance my slide. A little bit about Kroger. Kroger, we are a massive corporation. Not only do we do retail stores, but we have a lot of manufacturing and transportation. We've been around since 1883. Last year, 2020, our revenue was $132.5 billion for that fiscal year. As you can imagine, we are extremely busy. As people transitioned from restaurant, country club, hotel, and travel to buying food and preparing foods at home, and people were getting interested in baking again and cooking at home, our sales were absolutely outstanding. And for many of you who shop at Kroger, we thank you for that each and every day. So Kroger, as of August 14th of 2021, we operate 2,800 supermarkets and department stores across the country. In my region, I'm responsible for, as Captain Otto said, 183 stores in 3 states, Alabama, South Carolina, and Georgia. So where were we? Back when the pandemic first started, I'll first tell you that we've always had pandemic coordinators, and we always had risk assessment. And that's a division that I was a part of in the operational field. So what we do is 26 divisions, East Coast, West Coast, we maintain our pandemic plans for as long as I can remember. And what that entails is really going through all of the associates, all of the executive group, anybody who would be in retail, merchandising, and we have all of their personal information so that we know who to contact, where to contact. We do a lot of internal cross-training to ensure that if anybody were to ever fall ill in one of those specific areas of operation, we have somebody who can step in and take control. We also have the ability to work from anywhere. So we have an amazing technology department that allows us to work from a particular store or from at home or from our corporate office. Workspaces and computer accessibility is key for us. We also have plans in place for all of our stores in the event we had a high transmission area. What we would do in that event would be to close a department or close a store. And throughout SARS-CoV-2, we've had that situation come. We also keep updated with all of our partners, all of you out there, State Department of Agriculture, Public Health, CDC, and all of those that we work with on a daily basis. So as you can imagine, you were all in it with us. We were there February, March in 2020 when the pandemic started rearing its ugly head as to what to come, a lot of fear, a lot of what ifs and what are we going to do. We immediately held meetings with all of our partners out there, many of you with the State Department of Public Health and Department of Agriculture. We were on the phone constantly talking about plans, talking about what we are going to do. A collaboration, it was absolutely necessary. We began to stock up on all of our MPDC sanitizers and NPIs because we knew that they were going to go very, very quickly, and many of them did. That picture you see there, empty shelves, I'm sure you all experienced some of that at some point. A lot of anomalies during the outbreak as you can remember, the toilet paper outage, that was one that threw us for a loop. I'm sure it did it for all of you as well. Multiple items we were trying to make arrangements from all of our suppliers to ensure that we had enough to keep everybody safe. Items such as hand sanitizers, wipes, glove usage, toilet papers, cleaning utensils, et cetera, et cetera, et cetera. So that was all available to all of you, and we still maintain that currently. So what do we do? When it really started getting bad, we pulled together all of our teams, multifunctional teams from East Coast, West Coast, from our corporate office. As I said, we have 26 divisions, East Coast, West Coast, all with a corporate office. And then we have one main office in Cincinnati, Ohio. What we did is we got together with all of our folks and we had conference calls daily. Things changed, they were fluid. You remember hearing this word quite a bit during the pandemic called pivot. What are we going to do? We're going to pivot. We're going to change. We're going to lead operations into this directions. All meanwhile, keeping our associates safe and informed. That's the key, because there was a lot of fear with a lot of our associates. What are we going to do? How are we going to do it? And that was our job. So as you can see here, this is just a number of folks who we all got together, our asset protection teams, continuity teams, facility engineering folks, health and wellness, human resources, manufacturing, marketing. All of us were on one call daily to ensure that everybody was informed and keeping clear with CDC recommendations, state regulations, everything that we needed to do to keep you, our customers, and our associates safe. So as you talked about the MPIs, the two presentations that were done were extremely well done. We talked about it as well, and we started promoting all the healthy habits and doing our coaching, teaching, and training, encouraging the physical distancing, enhancing cleaning procedures with MPDC, multi-purpose disinfectant cleansers and sanitizers. And you know, as busy as we were, and we were extremely busy, it's the busiest year we've ever had. And if any of you had been in Kroger stores, I'm sure you have, or even our competitors, Publix, Walmart, extremely busy. It put a lot of stress on our associates. So we actually adjusted our operating hours to not only give them a break and to get them rejuvenated, but also to add our cleaning and disinfecting protocols to keep our associates and our customers safe, and the ability for us to restock. So we encouraged our employees to use personal protective equipment, and with that comes quite a bit of training. Majority of all of our associates never even knew what a surgical mask was. You know, you see them in the doctor's offices and so on and so forth, but items such as how to properly wear, how to properly dispose of, when to take them off and change them out, how to dispose of them. What about the ones that are washable? Do you wash them on a regular basis? So we actually encourage the medical grade masks, and we provided those to all of our folks. And that was something that was never in our readily available, but we did have access to them. And as you can imagine, every retailer in the country, in the world, were vying for positions to get all of these NPIs and cleaners and sanitizers. So that's where we had a little bit of a bottleneck, I would say, in that we needed to get all those items. And sometimes we were out of them and we had to borrow from other stores, et cetera, et cetera. And we also established vendor guidelines. Who's coming into our stores? They need to follow the same protocols that we're following. And they were all very amiable, and they all did that as well. We did quite a bit of contact-free checkout. And for those most vulnerable, we actually put together special operating hours for seniors and those who already had, those who were high risk. And those are the things that we need to think about for our customers, and that was very much appreciated. So as I talked about those masks, and you know, we talk about the N95s, et cetera, we were unable to use those because, again, that would be an OSHA situation, and some in-depth training would have to be done. And we we went with the medical grade surgical masks and did extensive training programs. How do we do that? We did it internally via conference calls, but we also had done daily emails to all associates. We all have an internal web system that they all look at, and we also set up text messaging for people to go and look at. Hey, we have a new protocol on proper hand washing, et cetera, et cetera. So being in the food industry, we know hand washing, very important, which we do every day. Now we add on to that the glove usage, and then the mask wearing. So now it's very important to make sure not to touch your mask with your hand or your glove. So all of that had to be a continual everyday education as well. As I said, the employee and customer safety was our #1 priority. As you can imagine, with over 1 million employees across the country, including the retail stores, the manufacturing plants, distribution, we have office buildings, we have district staffs. It was very challenging, and we were getting exposed. We had people who were getting exposed. What do we do in those events? Even though we're trying to do our CDC recommendation of it was first 6-foot social distance, as you can imagine, trying to even get those stickers made, that was a challenge as well. Get them out to stores, get them up and do it very quickly. It took an effort of everybody involved, from our manufacturing facility, our buyers, our merchandising group, our operational group. It was very well done. What we also did is we worked with our digital team to collect data on areas where we had high levels of community spread throughout the country. That will allow us to get them additional assistance, additional product in a timely manner, and to not only service our associates, but also the customers in that high exposure area. As we know, being on the front line, we are exposed, and we had many that were falling ill as far as being positive, and we followed the CDC recommendations of the quarantine. And as you know, when we work with State Department of Public Health and County Health, contact tracing, it was so overwhelming at that time. What we were working with was all of our state and local to make sure that we did our own internal contact tracing, and we were changing some hours in regard to work protocols. What does that mean? Well, as you can imagine, we have pharmacies where we have very close contact of those pharmacy representatives and the pharmacists, as well as the workers in that kiosk area. If we had a pharmacist who did multiple hours, evening and morning, we put an end to that very quickly, so that if in the event somebody fell ill in a morning shift, we wouldn't spread in the evening shift. So we had to change that up, and that was something we didn't think about until we started seeing high levels of infection with those folks who are in close contact. So that was something that we had to really pivot on and work that out very, very quickly. This is an example of what we put together with our state and county folks and Kroger to do some contact tracing. I know county and as well as state and all of us were extremely overloaded, so it might have taken quite a long time for state to get back to us. So what we did is we worked out where we would do our contact tracing immediately and quarantine all of those who might have been exposed to limit any kind of infection. And it's been working out for us very well. So our corporate office, as I said, we met with those folks, and some of the questions we would ask and things we would find out by use of camera: who was exposed? Was it a lengthy time that they were exposed? If they were, then we were going to quarantine those folks to keep infection rate down. So how long were they going to be exposed? Was it within a particular area? And if we needed to close that department, we most certainly did. Areas where we closed more often than not, as you can imagine, very close contact, it was Starbucks and pharmacy. Our main goal was to educate and communicate not only to our associates, but also to the consumers. posting signs at time clocks on proper mask usage, importance of following all protocols. And then what we did was have huddles daily. Huddle would be where our store leadership would get with all departments and talk about what we needed to focus on for that particular day. Encourage the employees to follow the recommended hygiene practices. Again, throughout, the more we learn from CDC recommendations, the more we put into place. This is in the beginning. We had in-store radio messaging to remind not only the associates, but also the customers to follow all the social distancing protocols, and please not to come in if you're sick. Posted the signs at the entrance, and we increased availability of hand sanitizers, wipes, and cleaning of frequently touched surfaces, including our carts. So we had manned stations. We added hours to clean and sanitize the cart handles, any touch points that might have been in the store. Not only did it help with the perception, because customers, when they see that, they feel more at ease, and we were doing what we needed to do in order to prevent the spread. We added labor to cover additional breaks for employees to wash hands and sanitize, especially the front end associates. The front end associates were the ones who were in direct line with all those consumers, and some of those consumers did not wear masks. So those are some of the things that we had to really get over for the most part. And if you can think about when you go into a grocery retail store, how many touch points there truly are. There are many, many touch points, from freezer handles to buggy cart handles, credit card machines, doors, you name it. Unbelievable. Not only front of house, but also in back of house. So we put together protocols on how to clean, sanitize, and disinfect all of those on a daily basis. So we also did a couple of things to help protect our associates, items such as halting returns. If it went out of the store, it didn't come back in the store. And we also work with State Department of Agriculture in regard to shutting down some of our self-service areas, items such as roll bins, donut bins, bagel bins, salad bars, and all of those things that had high levels of touch point. So I'm going to go back because that was something that was very interesting. When we talk about reusable bags, our associates were very concerned about handling bags that were coming in from consumers, not knowing whether or not they'd been cleaned or sanitized. So we would always encourage the use of reusable bags. In order to keep our employees safe, we asked the customers to do their own bagging at point of purchase. And that put our associates at ease as well. Proper glove usage, not only for those who are handling food, but anybody who would be handling any kind of MPDC, sanitizing, as well as associates who are on the front line who wanted to wear gloves on the front ends, bagging groceries, et cetera, et cetera. We had a protocol for them to wash their hands and change their gloves in a timely manner, and how to properly dispose of those as well. As the pandemic continued on, we installed protective plexiglass screens in front of the cashiers. I'm going to actually toggle to it so you can actually see some of these things that we did. You see the top right-hand corner is where we had our plexiglass screens for pharmacy as well as front end to prevent any kind of exposure, droplet or otherwise, from somebody who may or may not be wearing a mask. We also encouraged mask usage, not only the surgical mask, but also the cloth mask as well, as we talked about those double masking. Closed all of our in-store bars and public seating areas to prevent people from gathering. We discontinued our sampling programs, and we closed, as I said, all self-service areas and closed fitting areas to limit capacity as well. We had capacity limits in our jurisdictions as well. We tried to cut it down to 50%. And technology you may or may not be aware that Kroger has, we have heat sensing devices at our door whereas you walk in, you're counted, and that's how we determine how many registers to open at a particular time based on algorithms of time of day and day to know how many registers to open. If you ever go to the Kroger store on the front end, if you look up at the giant screen, it looks like bingo balls, 3, 5, 2. That's how many registers we should open within X amount of minutes. So next time you're out there, take a look at some of those. It's pretty interesting. You may or may not have known. And then when we reach that 50% capacity, we would limit those coming in. Some other pictures that you see there, those floor decals to encourage social distancing, not only on the front end, but also in our areas where we were still servicing customers, meat and seafood, as well as deli areas. We also instituted some protocols for being able to come to work. We encouraged those to take their temperatures prior to coming and not to come at all. But to double check that, we actually had thermometers in store to check everybody's temperature, made sure that we had fully thought protocols. We had all of our equipment needed, and we encouraged anybody who felt ill to stay home. We revised all of our paid time off positions, and we supported them throughout and did an emergency leave guidance as well. We actually paid our employees, anyone who was under quarantine, we paid them as well, so that everybody felt very, very comfortable in discussion with that. Because as you know, hourly associates, they need the money. They're going to come to work. You know, we've had that problem in the past. You've probably seen some documentation on that, or some studies done, that if you're an hourly associate and you have mild symptoms, or maybe you're having some symptoms, you're going to come to work. Why? You need the money. So we really encouraged our folks not to come in, because it's that important not to spread it to their coworkers and to their valued customers. I talked about earlier about how we did cross-training in the early days to fill any gap if we had a number of call-outs or quarantines in a particular department, milk department for that matter, or dairy. We would be able to step in at any given point, and we can actually take care of that and service the customers the way we need to do. All of these things that we did throughout the pandemic, we actually put together what we call the Blueprint for Business Success, and it offered cross-industry coronavirus action plans. We put that together and we shared the knowledge. I'm very, very proud to say that in April, as quick as it transpired, in April of 2020, we shared all of that information at a meeting at the White House in Washington, D.C., and it was a 17-page document that was put together with all of those operational and merchandising folks, manufacturing, as well as transportation. And we shared that with all of industry and some other, like Georgia Association for Food Protection, where it's a collaboration of grocery retailers and retailers throughout the state of Georgia. We shared that as well. We shared it with schools. We shared it with anybody who wanted to utilize it. And it went over very well. There's a link on there as well if you want to take a look at it. It's a very interesting read. And it shows all the protocols, the MPIs, and everything that we're currently doing. So we talk about vaccinations. Kroger, we're highly encouraging all to get vaccinated. And we actually have a medical officer on staff. His name's Dr. Mark. We work with him very closely on educating not only the consumers, but our associates to say how extremely important vaccinations are, and to give them as much information to have them understand why we want to do this. Kroger was one of the big companies that put together a plan. We gave away $5 million in vaccinations, whereas if you got vaccinated at Kroger, you were put into a drawing to win 5 $1 million prizes. I'm guessing none of you have won, because you wouldn't be on this presentation listening to me at that point. So, but what we also did was we gave associates incentives, $100 to get vaccinated, and we made them easily readily available for them at all times. Our plan currently with our booster shots is going to be 1 million COVID booster shots, and we're going to be going to nursing homes as well to help get everybody vaccinated. As of last week, we had just under 7.4 million doses administered throughout the country, and we carry all 3 types of vaccines. And so hats off to not only Kroger, but also to all of those pharmacies and competitors that are out there on the front line doing vaccines as well. We thank you for that. So in conclusion, what I really want to tell you is this. Kroger is currently operating as if we're in full-blown COVID, as we should be. We still will be doing all of our protocols. Our NPIs, our masks are required for all associates to come to work. We're still doing all of our cleaning, sanitizing, and disinfecting, and we are working very closely with all the state, local, and CDC on updated guidance. As it comes out, we get it out. And I want to thank all of you. I see all of these names on here, and I've worked with you in the last 18 months very, very closely in many, many aspects of what we're talking about here today. Because again, the folks who are shopping at Kroger, for those of you who know me, and those of you who know that I teach food safety to all of our food, for all of our store managers, I don't call those folks customers. I call them friends and family. Everybody who's shopping in there is a friend or a family member, because you could be shopping in my store, I could be shopping at your store. So safety and the well-being of all of our customers and our associates, the most important thing. And we're engaging employees every day with our pandemic response. And I feel like they are completely, when you show that you're educating, your employees trust you. And when they trust you, you're going to get things done. And I appreciate you listening to me. Our people are our greatest asset. Never forget that. Your people are your greatest asset. And I thank you so much. You get to see me again, because now I'm not shoveling through a bunch of papers with some of my notes on there. I'm going to open it up for questions, and I thank you for listening. Over to you, Charles. Captain Otto.
Thank you, Chef John. Excellent talk. If everybody would have joined me with a kudo for stepping up to the plate, not only dealing with the pandemic, but delivering an excellent presentation here for the group. If we've got any questions, go ahead and enter them in the chat box. One thing I wanted to start off with was how in the world did you coordinate keeping all of those employees there to service your customers coming in? It had to be just a daunting challenge to balance all of the things going on in terms of individual scheduling. What tips did you give the store managers?
What we talked about was, be open and honest. Let's give all the information that we have, and know, when you know that you're a frontline employee, where you need to have food for not only your customers, but your friends and family, that takes it to a whole new level. So there was no hesitation on our part to get everybody out there. I will tell you, there were some folks who were very afraid, and with fear comes education. The more you educate, the less fear. So we showed what we were going to do to help protect them and to protect the public, and that put them all at ease. Now, some of them didn't come to work, mind you, because they were extremely afraid, and we expected that.
I'm in one of those high risk categories, so I completely get it, Chef John. So the high risk is age. So I crossed that line a little while back. One of the questions from the audience was how many of these pandemic response measures are going to be kept in place once we get this behind us? I'm looking forward to that day too, but are there lessons what you learned that are going to carry forward, do you think?
Oh, I truly believe that. Yeah, we've learned a lot. We've actually, we have no plans on discontinuing any of the protocols currently. And the world has changed, and we know this. We see the world has changed. It seems as we transitioned out of restaurant, and again, being a chef and on the board for the American Culinary Federation for many years, as folks transitioned to that, they got more comfortable with cooking at home. So we are going to be extremely busy. Areas of our business where we saw a little lull, in example, baking. Baking is big around the holidays. Now baking is big all the time. Who would have thought? Who would have thought that you would go in a Kroger store and not have yeast to bake bread? Do you know that? That was a big anomaly as well. Who would have thought that, baking sourdough bread was going to be a thing? I love it. I think it's great. So yeah, there things have changed.
Mm-hmm. Yeah, that's great. That's great. If we've got any other questions, I'll ask you to go ahead and put them into the chat box or send them to the GAFP website. We'll get those answers back to you. Again, thank you for an excellent job, Chef John, and all of the students. We are getting great feedback in the questions there. And with that, I'll turn it over to our president, Katie.
Thank you so much for your presentation, Chef John, and Captain Otto. Thank you for moderating our conversation. If we can move on to the next slide, I just have a few brief updates we wanted to share with you before we close out our webinar today. The Georgia Regulatory Breakfast is occurring on November 9th. From 9 to 12 a.m. Eastern, and registration is free. It will be a virtual event, but it's a great opportunity for each of you to hear updates from FDA, USDA, our colleagues at the Georgia Department of Agriculture and the Georgia Department of Health. So we'd really encourage you to visit the link to register. We will have this posted on our Georgia Association for Food Protection website in the upcoming events section as well, for ease of access to register for this event. We also, of course, will continue our thoughtful programming for you, our membership, and are actively working under the leadership of Captain Otto with the program committee on a COVID-19 industry roundtable discussion scheduled to occur sometime in December or January. So stay tuned. You'll receive some communication from us, and the best way for you to stay up to date on all of our offerings is to complete or renew your registration and ensure that you are included on our listserv when we send out updates about different events and registration information. Finally, again, thank you so much to the Georgia Manufacturing Extension Partnership at Georgia Tech. If you're interested in learning more, we'd welcome you to continue the conversation by connecting with them on LinkedIn, Twitter, or Facebook. At their respective handles that are pictured here, or you can find them directly online at the Georgia Manufacturing Extension Partnership.org. And I see actually that Wendy's included the regulatory breakfast registration in our chat, so no need to even visit our website. It is there for you. Please click the link that Wendy's provided. Thank you, Wendy, to register if you're interested in attending. Finally, thank you for joining us today. We're thrilled with the participation that we saw. And I just want to send, a final moment saying that our board and program committees look forward to continuing to advance our mission of sharing information to protect the food supply and safeguard public health. When the time is right, we do look forward to welcoming our membership back together in person, likely in a hybrid approach. To discuss recent developments in food safety, to provide networking opportunities, and of course, to continue to provide professional development opportunities for our members. So we will keep you posted. For the time being, though, we will continue in a digital format for ease of access to our membership. This past year has taught us nothing if not to be resourceful and resilient. So you can expect to see our organization embrace opportunities to connect and develop virtually in this new format that we're operating in. So thank you so much. We look forward to connecting with you online and in person when the time is right. Appreciate again all of our speakers, Chef John, Xinran, Kane, and Julia. Wonderful presentations today. I think I speak on behalf of our audience. And I thoroughly enjoyed and really appreciated the time you put into sharing information with our membership today. And I wish you all health and safety. Thank you so much. And you can find this recording posted on our Georgia Association for Food Protection website. Thanks so much, everyone. Goodbye.